Hello everyone. We are going to pick up where we left off and work on solving equations that contain fractions. This is the other half of lesson 2.7. Please update your table of contents, and here we go. We will be working on solving equations that have fractions in them. Our first problem, our equation is n plus 2/7 is equal to a negative 3/7. And we always start off by drawing our line through our equal sign so we can determine which side is the left side and which side is the right side. On the left-hand side, we have n plus 2/7. So the opposite of adding 2/7 is to subtract 2/7 on both sides. Remember, we want to make a zero pair so that we can isolate our variable of n. Now, take a look at what we have on the right-hand side. Draw yourself a box. Look at the two numbers. Look at them as two separate numbers. We have negative 3/7 and we have negative 2/7. Are the signs the same or are they different? In this problem, they are the same. And what do we do when signs are the same? We want to add these two numbers together. 3 plus 2 is 5. The denominator stays the same as a 7. Now, because we have signs that are the same, we're going to add like normal and keep that sign. So we have an answer of negative 5/7. Go ahead and plug that in to check. Negative 5/7 plus 2/7 should be equal to a negative 3/7. Negative 5 plus 2 over 7 should be equal to negative 3/7. And just double check my math. We have signs that are different, subtract, and take the sign of the number that is further from 0. So I know my answer is right because when I substitute it in to check, it comes out even. Let's try another one. This time I have y minus 1/6 is equal to 2/3. Again, your line through your equal sign. As you can see, we are subtracting 1/6 from both sides. The inverse of subtracting 1/6 is to add 1/6 to both sides. Remember, the reason why we are adding 1/6 is so that we can make a zero pair, so the variable can be isolated. Now let's take a look at the right-hand side. We need to add these two fractions, 2/3 and 1/6, but we have a problem. They do not have a common denominator. So we need to make sure that they have a common denominator, and I can see that a common denominator for 3 and 6 is going to be 6. So I'm multiplying my 2/3 times 2 over 2, which gives me 4 over 6. And now I can add because we have to have a common denominator anytime we add. When we add our numerators, we end up with 5, and the denominator is 6. So we have y is equal to 5/6. Let's check our answer to make sure we're right. 5/6 minus 1/6 should equal 2/3 when we're finished. Subtracting on the left-hand side, I end up with 4/6, which is equivalent to 2/3. And let's just simplify, because we would divide both the numerator and the denominator by 2. And yes, 2/3 is equal to 2/3. So I know my answer is correct because when I substitute the value in for y, we get an equation where 2/3 is equal to 2/3. Our next question is just like the first one that we worked on. I have n plus 1/9 is equal to negative 5/9. Line through the equal sign. Subtract 1/9 on the left. Subtract 1/9 on the right. Zero pair. N is equal to, I'm going to draw a box. The signs are the same. And I know anytime the signs are the same, we want to find a sum. Add those numbers together. Adding the numerators, we have 5 and 1, which is 6. The denominator stays as a 9. And because both of those numbers are negative, my answer is a negative 6/9. Is that in simplest form? It is not. Remember, all answers must be in simplest form. I can divide both the numerator and the denominator by 3 to get a final answer of negative 2/3. Let's check to make sure our answer is correct. Negative 2/3 plus 1/9. We should end up with a negative 5/9 when we are finished. We need a common denominator for 2/3 and 1/9, and our common denominator would be 9. I'm multiplying both the numerator and the denominator by 3. I now have negative 6/9 plus 1/9 is equal to negative 5/9. Negative 6 plus 1 over 9 should equal negative 5/9, and it does. Check. Okay, so we've done 3 examples with adding and subtracting. Let's switch gears. Our next question says 5/6x is equal to 5/8. Line through the middle. What operation is happening over on the left-hand side? Well, you can see on the left-hand side that multiplication is going on. You have a coefficient of 5/6 being multiplied by x. The inverse of multiplication is division. However, we do not want to write complex fractions. So to get rid of 5/6 and isolate our variable so that x is by itself, we need to multiply by the reciprocal of the coefficient. What's the reciprocal of the coefficient? The reciprocal is 6/5. And remember, with equations, you want them to stay balanced. So whatever you do on one side, you must do the same on the other side. The reason why we need the reciprocal of the coefficient, remember, with multiplication and division, we're not looking for a 0 pair. We are looking for 1, the whole number of 1x. Now we can focus on the right-hand side. 5 divides into itself 1 time, and 2 will divide into 6 3 times, and 2 will divide into 8 4 times. We end up with an answer of x is equal to 3/4. Let's substitute that value in for our equation. 5/6 times 3/4, and in hopes of reaching 5/8. 3 divides evenly into 6 2 times, and 5/8 is equal to 5/8. So I know my answer of 3/4 is correct. Now I've helped you out quite a bit with our next two story problems. Mr. Rios wants to prepare a dessert, but only has 2 2/3 tablespoons of sugar. If each serving of the dessert has 2/3 tablespoon of sugar, how many servings can he make for the party? We are going to write an equation to help us solve this problem, and we are going to use total servings times the amount needed for each dessert is going to equal the amount of sugar that you currently have. We don't know how many total servings. That's our opportunity, or this is what we're trying to find, so that's going to be our variable. Total servings I'm going to represent as n. Amount needed for each dessert. Well, go back up and read the story problem. How much sugar do you need for each serving? Each serving of the dessert needs 2/3. So this green box is going to be 2/3. In the amount of sugar that we currently have, Mr. Rios has 2 2/3 tablespoons. So you'll notice over here on the left-hand side, we are going to be multiplying. We have a variable and we have a fraction. I want to rewrite that. I want to write that where the coefficient is first and the variable is second. I'm going to extend the page. So now, when we rewrite this, as I said, the coefficient first and the variable second. We have a mixed number on the right-hand side of our problem. Let's go ahead and convert that into an improper fraction. 2 2/3, remember we're multiplying and then adding. We end up with 8/3. Now look back at how we solved the very last problem. I need to isolate the variable of n, which means I need to get rid of the 2/3. The only way to get rid of the 2/3 is to multiply by its reciprocal. We do not want to work with complex fractions at this point in time. The reciprocal of 2/3 is 3/2. We'll multiply both sides by 3/2. Make our 1 on the side where our variable is located, and cancel. 2 divides evenly into 8 4 times, and the 3's each turn into 1. 4 times 1 is 4. Now it is a story problem, so make sure you put a label on it. And we have 4 servings that we can make for the party. One more story problem. This time we're going to talk about gasoline in a car. Rick's car holds 2/3 the amount of gasoline as his wife's van. If the car's gas tank can hold 31/2 gallons of gasoline, how much gasoline can the tank in the minivan hold? The van's gas tank is what we are looking for, so that's going to be our variable. The ratio of the car's tank to the van's tank, we're looking for a ratio, car to van. Rick's car holds 2/3 of the van. And the capacity of the car's tank, the car's gas tank can hold 31/2. Again, I'm going to extend the page. We want to rewrite this equation so that we have the coefficient before the variable. 2/3 n is equal to 31/2. And again, the only way we can get rid of our coefficient is to multiply by its reciprocal. 3 over 2 on the left, 3 over 2 on the right. Remember, by multiplying by the reciprocal, we end up with our one variable. Now look on the right-hand side. Can I cancel anything? Unfortunately not. 31 times 3 is 93. 2 times 2 is 4. And we now have to convert that into a mixed number. 23 and 1/4. It's a story problem. Put a label on it. Gallons. Again, we will practice tomorrow during class. Lots of equations that contain fractions. In the meantime, I would like you to try questions 7 through 12 on page 94. Please do it on your own loose leaf paper and come to class tomorrow with any questions that you may have. I hope you all have a great evening. Good night.